So I'm so sorry I actually pressed the mouse and accidentally hit the stop button. So like I was saying, you could have different um, shapes or you could have different colors of the same shape. So here I'm showing circles with different colors to represent different elements. But I could do where I have, a box and a circle if I wanted to. So this is showing the compounds having two or more different elements. Notice in the diagram that the different elements are actually in contact with one another. And that's really important because that shows that they're chemically connected, they're chemically combined. You'll see in a mixture that that's not the case. Now, when you have these compounds that have elements that are chemically combined, it means that the elements in those compounds could return back. You could chemically change them back into the lone elements. And so the way that they ask this is they say, which of the following substances, so you know it's an element or a compound, can be chemically broken down. And so compounds can be chemically broken down. Whereas if you were to have an element can't be chemically broken down. So let's look at what a mixture looks like. And so we said on the previous slide, elements and compounds, they're pure substances, they're homogeneous. It turns out that a mixture could be either homogeneous or heterogeneous. And that's because with mixtures, you have two or more substances, and remember, a substance is an element or a compound, so two or more substances physically combined. Because you're physically combining them, there's a few things that happen here. You could have a situation where you could be heterogeneous, or you could be homogeneous. And you could also have a varied ratio of components. And that's because you're physically combining them. So there's no guidelines really to how much of each thing you can add. If you want to make iced tea, for example, you could put in, either a lot of iced tea mix or a little bit of iced tea mix. If you are, like mixing together a salad, you could have, a lot of lettuce or a lot of tomatoes. There's no real guidelines as to how much you should add. With a compound, because you're chemically combining things, they need to be combined in an exact ratio, otherwise it won't be the right compound. And that's really important. Now with a mixture, with heterogeneous, that means that you are not uniform. Whereas with homogeneous, again, you are uniform. Homogeneous mixtures, they have a special name. They are called solutions. If somebody mentions something being a solution, then it means by definition that you are a homogeneous mixture. The most common solutions are where you have water. Water's the thing dissolving. It's salt water, sugar water, any kind of solution that has water in it gets the designation of being aqueous, Aqueous. For those of you that take a foreign language, you probably have heard like agua or aqua, meaning water. Now, how can I go ahead and draw a mixture? Well, my mixture, if I were to have, different elements mixed, as opposed to being a compound, I'd have some of one type of element and some of another type of element. If I wanted to try and show a heterogeneous mixture, I could have it where all of the one type of element are kind of clustered at one part, and the other type of element is clustered in another part. Examples of heterogeneous, non-uniform types of compounds, which I'll put here in this blue color, that purple, that purple color, those are going to be things where you have like soil. or if you were to have, cookie dough ice cream. Because they're not uniform. If you go and you dig up some soil, there's regions of the soil that has more roots, has more rocks, has more organisms. If you were to scoop out some cookie dough ice cream, sometimes you're really happy you get that great piece of cookie dough where there's tons of chocolate chips and actual cookie dough, and then you get another scoop and it's all vanilla ice cream. Heterogeneous mixtures, non-uniform mixtures, they tend to happen where you have different phases, solids and liquids, sand and water. Those will settle out. Homogeneous mixture solutions, those will mix together completely, and you won't be able to tell the components apart. You'll have a uniform composition. If you dissolve some salt in water, you get salt water. It's uniform throughout. Okay, let's talk about these phases of matter, which I've been alluding to. So we have these different phases of matter. There are three main phases of matter. We have solid, we have liquid, and we have gas. In the liquid phase, you could have an aqueous solution, AQ. And this is where you've dissolved something in water. And I put this here because it looks like a liquid, but in reality there's some other particles that are mixed in that are floating around within the liquid. So the solid gets the symbol S, the liquid gets the symbol L, script L, and the gas gets the symbol G. Now if you are solid, you have a definite shape and a definite volume. If I were to draw a solid, I would, I can zoom in here, I would have this definite shape and a definite volume. I could measure the volume and I could measure the shape. I could take this solid out of that container, put it in another container, the shape will be exactly the same, the volume will be exactly the same. This is non-compressible, so I can't compress it. That's first of all. And second of all, the particles are closely packed together. They're in a fixed position. If I have a liquid, well now I still have a definite volume, but I have an indefinite shape. So my shape can change, but my volume's still definite. So I could take my water and I could pour it out of my bottle here and I could put it into a glass and it will change shape, but the volume will be the same. I measured the volume in the plastic bottle and I measured the volume in the glass and it's identical, but the shape's different. And so if I were to pour some water into this container here, the water would take the shape of the container. It would fill it in the bottom. If this was an ice cube, a solid piece of water, it would fall to the bottom and it wouldn't take the shape. Now, because it has a definite volume, it's still non-compressible. And in class, I'll show you this with a syringe. I'll show you what it looks like where you can compress a liquid. The difference between a liquid and a solid, although the particles are still really closely packed, the particles can kind of slide past one another. So next time that you are actually, pouring a liquid, think of those particles sort of pulling each other along. They're still attached to each other, but they're able to tumble past one another and be poured from one container to another. Now, if I talk about aqueous, aqueous is where you still have liquid, it's liquid water, with dissolved particles in it. And so the way that they represent this is they'll actually have where you have the substance that's dissolved. So they'll put like NaCl, and then they'll put the little symbol AQ, and this AQ means that you have water dissolved inside of, or you have NaCl dissolved inside the water. The last phase of matter is gas. In gas, there's no definite shape. There's no definite volume. If I were to draw a picture of it, I would have the particles spread out. And we're going to do a whole unit just dedicated to gases. Gases are compressible. So we'll talk more about what it means to be a gas, but importantly now is being able to look at a diagram and tell what phase it is, and whether or not it has a definite shape or volume, and if it's compressible. Now, we've talked about different types of matter-element compound mixture. We also talked about how you can have different phases of matter. And the next important thing is, well, how do you separate a mixture? So I'm going to stop here for now, and on our next, on the next video that I make for you, I'm going to do ways to separate a mixture, and I'm going to do physical and chemical changes with you. So this way you can, get an idea of what those, and physical chemical properties, so you can get an idea of what those mean and why they're important. All right, thanks so much. See you tomorrow.